Hello everybody! We're going to talk about systems of equations and how to pick the best method to go about solving them. So we have learned three methods of solving systems of equations. The first method is the elimination method. That is basically adding together the two equations. Okay? The second method is graphing. And this one is the least accurate. And the third method that we have learned is substitution. Now, you might be thinking to yourself, I really only like elimination. And you may think that if you like, but I suspect that one of the reasons that you like the elimination so much more is because you've done it more now. And so you're comfortable with it and you can start to see how things are going to play out, before you do things in the problem. The substitution method can be just as helpful. And I do have to admit that I often avoid the graphing method, except on standardized tests. Sometimes the graphing method can help you a lot. And when you get ready to study for the ACT or SAT, or when we do sample questions in class, you might find that graphing is going to be much faster than either of the other two methods. Since there's so much time pressure on the standardized tests, it's a good method for you to know. In this class, though, probably you're only going to do graphing when Fred tells you to do graphing, and that's okay. So what I want to do is I want to look at a couple of different equations and see if we can figure out how we decide whether or not we're going to use the elimination method or the substitution method. So let's take a look at our first problem. I'm going to show you this one, number 1 here. We have 3x minus y equals negative 8, and we have 2x plus 6y equals 3. Now this is an example where it could go either way. Notice that you already have all of your equations lined up. You have your x's over your x's, your y's over your y's, and your regular numbers over your regular numbers. And so that means you might want to consider elimination because everything is already set up easily for you. Also, you have kind of small numbers up here, so it would be easy to figure out how to eliminate a variable. So for instance, you could just multiply this whole top by 6, and then you would have a 6y and a negative 6y, and life would be good. So I would probably go with the elimination method here. Now, you could use the substitution method and try to get y by itself, but I'd like you to notice that y right now is a negative y, which means that you would have to move this over and then multiply by negative 1 again. So it's a two-step process to get y truly by itself. And 2 steps is not as good as 1 step. So I'm going with elimination here. All right, let's take a look at our second example. Here we have negative 2x plus 3y equals negative 15, and we have negative 4x plus y equals positive 15. Which method would you like to use here? Okay, so you are correct that you could certainly use the elimination method, right? You could multiply this top equation by negative 2 and get a positive 4x. You could multiply the bottom equation by negative 3 and get your y's to cancel out. Either one of those is possible. I'd like to point out, though, that this equation right here has y almost by itself already, right? All we would have to do is move this 4x. We would flip it to the other side. And in this case, by flipping it, we would wind up with a positive number, right? Because we would also have to flip the sign. This would become y equals 4x plus 15. We flip the side, we have to flip the sign, so it becomes positive. So I kind of am liking the substitution method here, because now I have positive numbers that get stuck up here, and I don't know, it seemed pretty easy to me. So I would maybe use substitution. There's certainly nothing wrong. I left out a whole syllable there. There we go. There's certainly nothing wrong with using the elimination method. I would use the substitution method. So there you go. Let's take a look at this one. Again, we have our x's and our y's already lined up, so that's nice. And it would be pretty easy for us to use the elimination method here. In order to use the substitution method, though, that would also be pretty easy. For instance, x is almost by itself. I could move my negative 3y over and make it a positive. So x equals 3y plus 1. That would work too. So again, you could go either direction here. Let's take a look at this one. Oh, look I wrote the exact same problem down twice. Okay, well, I'm still going to say that we should use the substitution method, but no method is wrong. Take a look at this last one. This last one is an excellent example of one where you probably would not want to use the elimination method. Can you tell me why? Well, one of the reasons why is we don't, we already have x completely by itself, right? X is completely by itself. The other reason is because we have some big numbers here, like 32 and 15, which makes it harder to do that math in our heads. So, I don't know. I would do 3, and then wherever my x is, I'm going to put in 4y plus 15 minus 6y equals 32. I'm going to solve that one problem, or that one equation, and I'm going to know what y is. So, I don't know, that's just me. So here are the rules. Here are the things that you ask yourself. You ask yourself, are my variables lined up? Are the variables lined up? If they are, then it might be easier for you to use the elimination method. The second thing that you want to know is a variable by itself? Because if you have a variable already by itself, then it's very easy to use the substitution method. And the third is, how much work will elimination take? For instance, if you have like a 219x minus 436y equals 1983, right? If you have that equation plus x equals y plus 2, then you can say, okay, that would take a lot of work for me to multiply this together and then deal with these big numbers and stuff. So if you have too much elimination methods to, or too much work to do with the elimination method, then you might want to think about using the substitution method. Again, you have to use the method that Fred tells you to use, but if he doesn't tell you to use a method, you can solve it with whichever one floats your boat.